Hey guys, hope you are all doing fine. So let us continue the video of principle of superposition of electric field, which is the continuation from the previous video. Okay. So first of all, I would like to apologize from my side. That is regarding, I said I will be uploading the video of principle of superposition of electric field very soon, but I couldn't complete it due to various reasons, and I'm sorry for that. Okay, so let us continue with this particular video for this particular concept of principle of superposition of electric field. So first of all, you need to know what is meant by principle of superposition of electric field. It is like there are electric charges, they produce electric field. If that electric field is produced by multiple charges, then to find the total electric field, we have to add all those electric fields due to independent charges. Okay, so based on that we are going to discuss this. So look at this. So for example, if there are multiple charges and the electric field due to those multiple charges, okay, instead of a single charge, if you are having multiple charges or there are more number of charges, then by the principle of superposition, the resultant electric field intensity, it is given by E vector is equal to E1 vector plus E2 vector plus E3 vector. So what is meant by this E1 vector, E2 vector, E3 vector? Okay, so at a particular point, for example, just look at this. So for example, there are multiple charges like Q1, Q2, Q3. Okay, like I have taken 3 charges which are away from each other, and at a certain point, let us assume that Q1 is at a distance of R1 there, Q2 is at a distance of R2 there, and Q3 is at how much distance there? R3. Okay, so here if you each charge produces electric field at this point. We know that formula actually. Electric field is equal to KQ by R square. Okay, so by applying that, here Q1 will produce electric field E1 vector there, Q2 can produce electric field of E2 vector there, Q3 can produce electric field E3 vector there. So the total electric field vector at this point, let us assume that it is P. It is given by the summation of individual electric fields in vector form. That point, that is the summation of individual electric fields at a point in vector form, that is called as principle of superposition of electric field. Okay, so that we will see, and that application also we are going to discuss it today. I hope you remember the vector representation. That is, if you are adding any 2 vectors like this, that means you are going to find the resultant of the 2 vectors there. It is going to be the resultant of the vectors. That is, you might be remembering, that is, resultant formula is root over, for example, for E1 and E2, if you want to find the resultant, it is equal to E1 square, square root of E1 square plus E2 square plus 2 E1 E2 cos theta. Okay, where theta is the angle between E1 and as well as E2. Okay, so let us continue with this particular representation. Let us try to do some around 2-3 numericals based on this particular concept, right? Yeah. So that is what it is regarding the electric field due to multiple charges. That is, instead of single charge, if there are multiple charges are acting at a point, then the resultant electric field intensity is given by E vector is equal to E1 vector plus E2 vector plus E3 vector. The summation of these electric field vectors, we are calling it as principle of superposition. Now let us do a numerical based on this. So I hope you are able to see the question there. It is the two charges of 25 millicoulomb and 75 millicoulomb. They are separated at by a distance of 0.6 meter. Find the electric field of electric field. Find the intensity of electric field at a point midway between them. Okay, right? So look at this. So let us do this particular question here. Okay, right. So there are two charges plus 25 millicoulomb. That is, this is, you take it as 25 millicoulomb. And another one is 75 millicoulomb. They both are separated by a distance of 0.6 meter from each other. Okay, so we have to find the electric field at the center of these two charges. Okay, both are positive charges, my dear. Okay, so here if you observe carefully, first let us try to see the preliminary observation here. Okay, that is, now this is a positive charge, this is also a positive charge, 25 and 75 plus. Okay, they didn't mention anywhere minus about it. Okay, this positive charge will apply electric field away from the charge. From this 25 millicoulomb, the field will be acting away from the charge. Even from 75 millicoulomb also, it will also be acting away from the charge. So if you look at this, this is the electric field due to first charge and this is the electric field due to second charge. They both are acting at an angle 180 degree to each other. Okay, so here we understood what to do now. Okay, now let us try to find what are the electric fields in these cases. Okay, what is the net electric field at the midway between them, at a point midway. Point with midway means, that means exactly at the center. Okay, right. So first electric field due to first charge, it is equal to k q1 by r1 square. So what is the k value? 9 into 10 power 9 into q1 is 25 millicoulomb. Milli means 10 power minus 3 by R1. What is the distance of this point? As they are exactly at center, 0.6 divided by 2, it will be equal to how much? 0.3 whole square, which is equal to 9 into 10 power 9 into 25 into 10 power minus 3 divided by, this one we can write it as 9 into 10 power minus 2. 9 and 9 will get cancelled. So it is 10 power 9 plus 2, it is 10 power 11. So it will be equal to 25 into 10 power 11 into 10 power minus 3, which will be equal to 25 into 10 power 8 Newton per Coulomb. Okay. Similarly, E2 will be equal to K Q2 divided by R2 square, which is equal to 9 into 10 power 9 into 75 millicoulomb. No, second one, it is at how much distance? 75 millicoulomb. It is at how much distance? That is also at 0.3 meter, because it is lying exactly in the midway. That one, it will be, when you square it, you will be getting it as 9 into 10 power minus 2. Sorry, 9 and 9 cancel. Again, you will be getting it as 75 into 10 power 8 Newton per Coulomb. Okay. Now, here these both electric fields, they are acting at how much angle to each other? It is at 180 degree. Therefore, E resultant will be equal to square root of E1 square plus E2 square plus 2E1 E2 cos 180. Resultant we have to find, I have said. That is a concept about that principle of superposition. Okay. So it will be equal to root over 25 into 10 power 8 whole square plus 75 into 10 power 8 whole square plus 2 into 25 into 10 power 8 into 75 into 10 power 8 into cos 180 degree. Cos 180 value is minus 1, my dear. So if you substitute that there, if you substitute it there, you will be getting it as this minus 1. If it is like root over, it will be like 25. It is like a square plus b square. This minus, if you write there, it is like minus 2ab, which is like a minus b whole square. So I can write it as 25 into 10 power 8 minus 75 into 10 power 8 whole square. Square and root will get cancelled, which is minus 50 into 10 power 8 Newton per Coulomb is the answer. Why did we get minus? Because that electric field will be acting, net electric field will be acting towards left side due to this 75 millicoulomb. Is that okay? So that is regarding the finding the electric field due to the two charges at the point midway between them. Here comes the next question, that is two electric charges plus 1 nanocoulomb and minus 1 nanocoulomb are placed at the corners A and B of an equilateral triangle of side 5 cm. Find the electric field intensity at point C. Okay, so just have a look at that particular question there. So this is the next question, that is two electric charges plus 1 nanocoulomb and minus 1, they are placed at corners of A and B of equilateral triangle. And what is the side there for the triangle? Let me draw the triangle. I think this is better like this. Yeah. Sorry. Right. Let us solve it now. Like for example, if you assume that there are two charges, let me take this is point A, this is point A, point B, and this is the point C. And it's an equilateral triangle. What is the side of that equilateral triangle? 5 cm, 5 cm, 5 cm. They are asking the net electric field at which point? At this corner. Okay. So each point, or here there is a charge Q1 here. Here there is another charge Q2. Look at this. Now here let us again have a preliminary observation here, in which direction that force will be acting and all. Sorry, electric field will be acting and all. So first, due to this, Q1 is plus 1 nanocoulomb, my dear, and that plus 1 nanocoulomb, it's a positive charge. It will apply electric field in this direction, which is E1. Q2 is minus 1 nanocoulomb, which is, it will apply electric field in the downward direction like this. It will be towards the charge. Okay, so already this is given as an equilateral angle, so this angle will be 60 degree. Then obviously opposite angle, the other side angle, it will be equal to 120 degree. Okay, so this is E1, E2, and they are acting at what angle to each other, my dear? It is at 120 degree. Okay, now we have to find the resultant at that particular point. Okay, look at this. Once again, you will write all the given and all the other stuff. Okay, but here a direct line giving there, E1 is equal to KQ1 divided by R1 square, which is equal to K is 9 into 10 power 9, Q1 is 1 nanocoulomb, that is plus 1 it is, so it is 10 power minus 9 divided by, what is the distance given there? 5 centimeter, so it is 5 into 10 power minus 2 whole square. Okay, which is equal to 10 power 9, 10 power minus 9 cancel, which will be 9 by 25 into 10 power minus 4, which is equal to 9 into 10 power 4 by 25 Newton per Coulomb. Okay, next, electric field due to the second charge, that is the point which is at B, otherwise, right, due to the charge which is at B, it's a negative charge, minus 1 nanocoulomb, which is equal to KQ2 divided by R2 square, that is equal to 9 into 10 power 9. What is the charge? It is 10 power minus 9 because it's also a nanocoulomb. 5 into 10 power minus 2 whole square. because the distance is 5 centimeter here. Sorry, 5 meter I wrote there. It is actually 5 centimeter. 10 power 9, 10 power minus 9 cancel, which will be equal to 9 by 25 into 10 power minus 4. If you rearrange that, you will be getting it as 9 into 10 power 4 divided by 25 Newton per Coulomb. Here comes. Now we got that E1 and as well as E2. Now we need a resultant for this, that is E resultant, because it's a principle of superposition. This is the electric field due to multiple charges here at the point C, which is equal to root over E1 square plus E2 square plus 2 E1 E2 cos theta. Cos theta here it is equal to how much? Theta is 120 degree. Okay. Cos 120 it is equal to minus 1 by 2. This one you substitute there. It will be equal to, and one more thing. There is a small point here. If you observe E1, E2, they both are equal, right? Let us take them both to be equal to capital E. Only for an instance, my dear. Okay. For some time, I am assuming E1 and E2 both as equal to capital E. So it will be equal to square root of E square plus E square plus 2 E into E, it will be equal to E square. Cos 120 is minus 1 by 2. 2 cancel. So it will be equal to square root of E square plus E square minus E square. Plus E square minus E square cancel. So it is equal to how much? E, which is, what is the value of E, my dear? It is 9 into 10 power 4 divided by 25 Newton per Coulomb, and that is the answer. Hope you all got it. Okay. So that's regarding principle of superposition of electric field. If you need more questions based on this principle of superposition of electric field, just put it on a comment box. That if you want different models on this principle of superposition of electric field or electric field due to multiple charges, just give your comment properly in that particular comment section. So surely I'll be discussing in another video the remaining important models in principle of superposition of electric field. And don't forget to like, comment and share this video. Okay, and click the bell icon as soon as you subscribe it, because whenever I upload any video, you will be getting that video into your notification box if you subscribe and if you click on the bell icon. Okay, thank you all. Have a good day.